How's it going, everyone? Chris here with Simply SNUC. Now, when you think of robots, what's the first thing you think of? Is it the Terminator? Or maybe it's something more like R2-D2? Or maybe it's neither of those and it's something very realistic like Osimo, or maybe the Boston Dynamics robots. No matter what you think of, robots are all around us. They're building our cars, they're waiting on us at restaurants, and a whole lot more. But what are we planning to do with all this robot technology? What are robots going to be doing 10 years from now or 20 years from now? Now, I don't have the answers to any of those questions I just asked, but luckily, I'm going to bring on someone who might. He also might be able to answer some questions that I haven't even thought of yet. So with me today is Shah from Simbe. That's a company whose robot Tally is revolutionizing the way that retailers manage inventory. So let's bring him in. Welcome, Shah. Glad you could join me today to talk about robots.
Pleasure to be here.
Well, let's get right into it. It's going to feel a little broad, but the question is, why robots? What is so appealing about robots to industry and business?
Well, the big thing with robots, particularly autonomous robots, is that they have agency in the world. They can actually move around in it and do things versus just, software or a fixed piece of hardware. And the robot can actually move around. If it has a manipulator, it can, change things, move them around, pick them up. It can go into dangerous areas where a human being cannot go. It can do the tasks without getting tired and with perfect precision every single time. And it can do things that, human beings are just, maybe not designed for.
Simbe has a robot called Tally. How does Tally and other robots like it, how do they help retailers be more efficient and accurate?
Our Tally robots do inventory in retail stores. They go up and down the aisles, they capture the shelves with their cameras, and they upload that data to the cloud. And then that data is processed and turned into useful information that's used by, the store employees to do things like restock the shelves. Doing inventory is extremely it's an extremely painstaking task. Every shelf segment can have hundreds of products. So imagine you're a worker who's going with a little zappy gun, segment by segment, and they're scanning, each of these, barcodes and counting how many things are there. You could pay somebody $1 million a year to do that job, and they would still, be bad at it because it's so repetitive. The numbers start to blur together. The products start blurring together. Cherry Pop-Tarts and strawberry Pop-Tarts and raspberry Pop-Tarts, they all start to, look the same. So you make mistakes. According to industry reports, on average, the accuracy of inventory at most places is around the ballpark of 50 to 60%. So it's pretty much like a coin flip, a lot of the times. Whereas with our robots, we're hitting accuracies of 96 to 99, percent. And we're able to pick up every little detail. So even a little, small bottle of peanut butter, which has only one space, a person might not see it, but the robot will always see it. And the robot's able to do this every day, 7 days a week, 365 days a year.
With that in mind, that robots will go into environments that people maybe aren't suited for or are uncomfortable in, or it's too dangerous for them. What do you see as kind of the future of robotics? Is it starting to handle all those undesirable for human jobs, or is it just jobs where efficiency and accuracy becomes paramount?
I think of it more in terms of it changes, our existing workflows so that humans, aren't out of the loop, but rather they have a different role. So for example, with our Tally robots, we're not getting rid of people. Instead, we're changing their workflow. So now they're being, told directly on their handheld device, hey, these areas need to be serviced. And the end result is the store now has better stocked shelves than it did in the past when it was just human beings. Another analogy I could give you is like, before like the existence of spreadsheets, accountants used to have to do all of that stuff by hand, and the spreadsheets didn't make the accountants go away. It just made it so they could now manage more accounts and more complex financial models, which weren't possible before. So that's kind of where I see things going.
So you see it's less replacing, it's more augmenting. Robots are going to help us as workers be more productive and efficient, and they're not just going to wholesale like move people out. Because I think that's kind of people's fear in a way, is that, if a robot can do your job, it's just going to do your job and then you're out on the street.
Yeah. And I mean that fear is, justified, to an extent. But that's been true of, all technology, throughout human history. Yeah. And I mean, in Silicon Valley, they will use the term disruption. So things are disruptive because we're actually completely, turning upside down the way things happen.
I feel like robotics is becoming more and more prevalent, as is automation. What do you see as the biggest hurdle for robotics?
The big thing with robotics, and I think autonomous cars are a great example of this, is sort of like that last mile. So we're able to have robots do all these useful things, but there's lots of corner cases that have to be dealt with. Those are sort of like the challenges. So like we like to call them like the last mile, sort of challenges. So autonomous. There was a lot of innovation that happened in autonomous cars really early on, because that was like the low-hanging sort of fruit. Now it's kind of like the struggle is those like little corner cases. What happens when like a leaf flies by right in front of a sensor? Is the robot going to stop? So making robots more intelligent to meet human expectations. We're trying to determine how we can have these robots blend into the environment without getting into people's way and not causing any sort of accidents. The big challenge, and a lot of people are working on this, is creating like a humanoid sort of robot, which can just seamlessly adapt into our environment, so that we're not just redesigning our entire our entire environment to suit a robot.
Because that was when I asked my question about what's the next hurdle or what's the next challenge in robotics. To me, it always seems like it's a power issue, and it's a motor issue, like making servos small enough that you can fit them into a small kind of form to do the job they need to do without having giant, like hydraulic or pneumatic types things.
Yeah, you bring up a great point. My mind is usually not on manipulators because we don't actually have any. Tally is purely like a sensing platform. But yeah, you're absolutely right. In order to make like a humanoid robot or useful actuators, you need fairly large motors to create enough strength for that robot. So yeah, there's definitely needs to be innovation in that area of servos, and I think the power issue, that's not only an issue for robotics, but just for like everything, in general, like that's the holy grail is like what comes after like the lithium ion battery, what's going to be the evolution of that. And, a better battery is going to, not only change robotics, but, our electric grid, cars, everything.
Mm-hmm. Is it, in your mind, this is just purely conjecture on your part or your opinion, there's no right or wrong answer, but is it more important for computers to get smaller or more efficient for robotics?
Both.
That's a fair answer.
So yeah, both are important, especially of course if you're trying to build smaller and sleeker, sort of robots, you want to get smaller, and of course you want to be more efficient, because the more efficient you are, the longer you can last out there with the same amount of battery. So when we started Simbe, we were one of the first adopters of the NUC platform. So we're three guys in a garage, and Intel was gracious enough to send us samples of the very first NUCs.
Oh, really?
And yeah, and we've ever since then we've always used one or two NUCs. Our earlier robots used to use two NUCs. Now we only use one. But we've always used NUC computers throughout the history of our company, and it was extremely important to us because we wanted to make the robot as small and sleek as possible. So one of my co-founders, Jeff G, he's our chief designer. He's the one who designed the Tally robots and everything. And him being able to have that small compute platform, getting like an Intel i7 in like a little in a little tiny package, allowed him to create an extremely beautiful robot. And it's not just for aesthetics. It's important that the robot be small, because large robots are intimidating. There's been a lot of research that's been done into this from a psychological point of view. So for us, like the NUC was a game changer, and we've used it throughout our entire history and plan on continuing to do so.
This entire conversation was fascinating. I feel like I did learn a lot about robotics. And now I don't. Whenever you're talking about they've done studies, and the bigger the robot, I just kept picturing like the Terminator coming down the aisle, scanning things, and how that would intimidate people. So yeah, but thank you very much for joining me. It was, like I said, it was a great conversation. And for anyone watching, thank you for watching, and we hope to see you on the next one.
It was my pleasure. It was great talking to you.